in the food sector right now. I especially want to thank the team at ASI for inviting us to present and for hosting this event. As you can tell from the intro, Jason is clearly the smart one of us two, so he'll be handling all the technical pieces and any other technical questions at the end of the presentation. I am very familiar with SQF, BRC, HACCP, FSMA. Just receiving my PCQI qualification. I've been on dozens of sites, like Shannon said, from setting up systems to actually doing the testing in-house and helping figure out the plans. Everything from single shop operations to some of the largest packaging and bottling facilities in the country. So I understand we have a varied background of people on the webinar. So today what we're going to try to do is start with basically a general overview of the compressed air system. Run into specifications relating to compressed air specifically, and then into the requirements for the food industry. I'll hand you guys off to Jason for the analytical methods and validation methods, and then we'll come back and actually talk about how to apply that in a food facility as part of your guys' food safety plan or certification paths, and kind of how to figure out the points of use, what to expect during an audit, including some of the pitfalls and questions that we've heard and seen over the last 2-3 years as it's ramped up, and we'll finish with questions and answers. Like Shannon said, feel free to type them in. We'll address everything we can at the end. If we don't get to it, we'll get you guys answers very quickly after the webinar's over. So TRI has been around 41 years. There's a saying I love, it says, "Why trust the knowledge of a brickmaker about jewels?" It's from a book called The Richest Man in Babylon. Just means you know, get advice from people who actually know what they're talking about, right? You're not going to go down to a jeweler and ask him to build you a house. You're not going to ask a brickmaker to advise you on what diamond ring to buy for your fiance, at least not if you want to end up married to her. Same thing with air testing. There's a lot of misinformation out there, so hopefully we'll be able to plow through and kind of debunk some of that and give you guys some good guidance at which way to go. TRI was founded in 1975. We got our start testing for the United States Navy. Dr. Gala, who is still our lab director today, created a bunch of the methodologies and procedures for compressed air testing over the last 41 years. And then we went into fire, pharmaceutical, medical, and now that the food industry is coming on board, we're of course moving into that sector to help you guys out. We are an AIHA accredited lab. That's the American Industrial Hygiene Association, and we're CAP proficient. It's a round robin testing program that we actually helped institute with AIHA to prove that labs are good at what they do and able to do what they're telling you they're doing. We are the official testing lab for the U.S. military, the Center for Disease Control, and tons of other people throughout the world. We do about 30 in-house audits and certifications per year, including customer audits. And of course, we have employees who are HACCP and PCQI certified, just so we're familiar with the food industry. Compressed air systems all basically look the same. This is just a general line item overview, so I'm going to run you through the pieces real quick. It's a good idea to have this type of basic system diagram with your SOP or food safety plan to show to auditors when they come on site, and also to help you and your maintenance identify where your points of use and the specifications, the limits that you're trying to obtain from the types of dryers and filters you have in place. All compressed air systems, of course, start with the air compressor. The air compressor pulls in atmospheric air, mechanically condenses it, artificially increasing the pressure of it, and then pushes it out through your piping to whatever process you're doing. Typically, the food industry, we see between 40 and 4,000 psi for operating pressures. The 4,000 is basically your blow molding, packaging, bottling type operations. Everybody else operating pressures run between 70 and 100 psi at the point of use typically. The one thing to really pay attention with your air compressor is air compressors pull in atmospheric air, so wherever you locate it, that's the air that you're bringing in and putting into your process or using as an ingredient into your product. So if you have your air compressor outside and your dock guys have gotten in the habit of having big rigs parked next to it, you're now pulling all that exhaust fume into your facility and creating some issues for yourself. Likewise, if it's an indoor unit and your housekeeping, maintenance, facilities personnel have gotten into the habit of storing ammonia, chlorine chemicals that they leave open or empty mop buckets in that room, all that type of chemical will get pulled in and pushed through your whole plant. So it's just good to be aware of where your compressor is at and what we're keeping around it. So once the air is compressed, it goes into what they call an after cooler or a moisture separator. The whole purpose of these is to lower temperature and remove moisture. When air is compressed, it moves up to 100% relative humidity, and it gains a significant amount of heat, somewhere in the 400 to 500 degree range, just from the act of mechanically compressing it. A lot of the times you won't see these parts. They can be an internal part of a packaged air compressor, but all units will have them, so you will have them. After it leaves the separator, you go into a receiving tank. Receiving tanks basically just store the air. So if you have a bump in processes, you bring 2 production lines on, we'll be able to handle that extra workflow without surging the compressor or running shortage and messing up the operation on the floor. The more important parts of the system, as far as we're concerned from the food safety side, will be the next 2 steps, filtration. The purpose is to clean and dry, clean air to a suitable level, and it depends on the use of air. So if you're producing in a clean room, you're going to have much higher filtration. If you're using sterile air as an additive to a product, again, you're going to have much higher filtration. If you're just pushing air into the floor where you're blowing off excess product from a conveyor belt where you're also driving forklifts through, the air obviously doesn't need to be at the same standard as that sterile or clean air. So it's going to be very product and process dependent what we'll see here. The other control that we have in compressed air systems is a dryer. There are basically 2 types of dryers, refrigerant and desiccant, that we see used in food plants. Again, the level of dryness is going to depend on the product. Our chocolate guys, where moisture is going to cause some blooming issues or setting issues, obviously want their air a lot drier. Our wet product manufacturers, your bubbling water or something as you clean produce or fish, you're not going to care nearly as much about moisture. The big thing with moisture is it's probably the largest evil we have in food plants. You allow dryers quit working, and we allow moisture into the piping. It's a cool, dark environment, and if there's any contaminants, it becomes a great environment for growth. So the dryer is probably one of the higher failure rates we see, and also probably one of the leading causes to contaminants being spread throughout the system. A couple of the big fail points that we've had come back from customers, they'll have automatic drain valves, these items down here, and they will quit functioning because no one checks them. It'll actually fill this piping with moisture, and it'll exceed what the dryer can handle, and then it'll pass through the moisture to the system, often all the way out to the product. The other thing we'll see is they don't change their desiccant, or they'll have a refrigerant link, and no one's checking this item, and so you'll see that leak out to the product also. We've had chocolate plants that have serious blooming issues, and it's always come back to being a dryer. We've had some mold issues at a couple places, and again, it was dryer and drain valve issues. So if your maintenance people aren't checking that type of thing now, it's a good thing to add in as one of your protocols. The last thing in here is final filters. We call them point of use filters a lot in the food industry. This is what's going to get us down to that limit we want to be at. Currently, SQF has a recommendation of a 0.1 micron point of use filter, and the FDA has a 0.3 micron recommendation in some of their literature. The one thing to note with point of use filters is if we're going to use point of use filters to get down to that final limit we want to be at, you're also probably going to end up having to do a little bit more testing because you're going to need to sample after those final point of use filters. So if you have 10 point of use filters, you're going to have sampling 10 points. If you have single multi-stage filtration that gets you to that level that's feeding one branch main trunk line, a lot of times you'll be able to get away with a single point of use, and we'll kind of get into that in a little bit. That's the basic makeup of a compressed air system. From there, I think the important thing to understand is what regulates and what teaches us or tells us how to sample and what to look for in compressed air systems. And so from the compressed air side, we have one international standard. It's called ISO 8573. And I will not read you this whole slide, but I'll kind of hit the highlights. Basically, it's going to break it out, compressed air into purity classes, and it's going to identify types of contaminants: particulate, water, oil, chemical, gaseous, and of course microbiological. And then it'll give us ratings for most of those. The important things to note is ISO 8573 is probably the easiestly found compressed air reference, but it's not carried or referenced in any food certification or food regulation at this time. The British Compressed Air Society, the BCAS, makes a recommendation based off this, but even BRC doesn't follow that recommendation completely. The other thing to note is if you implement a ISO 8573 standard because you've been introduced to an overzealous filter or compressor salesperson, and you put that in your food safety plan, you'll obviously be accountable for testing to those limits as validations become a more in-depth part of our testing in the food industry. And that testing is much more costly than your standard compressed air testing. So if you don't need sterile air and you don't need clean room quality air, it's best to probably use what you have in place and test to that. And we'll kind of go over some of these ISO standards because it's the most referenced air. This is basically what it boils down to. It's the ISO 8573 Table 1 chart. You'll have your classes on the left-hand side, rating from Class 0 to a Class X, and then it's broken into 3 categories: particulates, water, and oil. What you'll hear is this, people say they have an ISO 8573 Class 2 or Class 242 or 642 rating. Those last 3 numbers are literally just breaking this in sequence. So if you have a 6, you're going to have 5 milligrams or less for particulate. If you have a 4 as your second number, you're going to be less than 37 degrees Fahrenheit for your moisture dew point. And if you have a 2 for your oil, you're going to be less than 0.1 milligrams. Again, there is nobody out there other than a reference from the British Compressed Air Society that will tell you what level you have to hit in your facility. Once you get your baseline testing done, it's a good reference to go back to and kind of see where you fall. The other things it will tell us how to test for and how to collect samples for is microbiological contaminants, but it has no purity classes or identification. It's not going to tell you where you need to be down to. It's going to leave all that up to us, and the same thing with gaseous components. The other body that governs how we test and what we look for in compressed air is the CGA, the Compressed Gas Association. They are a technical association that's been around for just about 40 years now, and they are highly regarded by the U.S. and Canadian governments to the point where DOT, FDA, the Canadian equivalents of those, Department of Homeland Security, all reference their requirements and standards. The CGA also provides test methodology that we'll follow for some sampling, but more importantly, it provides an actual hard specification for some fields. They focus primarily on breathing air. So if you're one of our people who have confined spaces, tanks that people have to get into, or rail cars, and you're feeding them breathing air, per OSHA, that stuff should be tested under the CGA Grade D breathing air spec, but they have multiple specs all revolving around breathing air. For us in the food industry, now that we know kind of what the compressed air system is, how we get to figuring out what all these contaminants are and what the components and how to measure them, it really boils down to what our certifying bodies say what's best for the safety of our product and our consumers and users. So we get a ton of questions because nobody will tell anyone what they should test for. So I guess the biggest question we end up with is, what should I test for? How do I know my air is clean? So what we went ahead and did is we created this chart here. We've taken the 3 biggest ones that we're seeing in the U.S., North America right now: SQF, BRC, and of course the FSMA code. We've built some recommendations off of our 41 plus years of experience and a ton of tests that we've had come back over the past 2 years. We've broken that down into an indirect and a direct product contact recommendation for clients. And then we've also taken the average limits that we're seeing reported on everyone from the food industry as a whole. So it would be food, beverage, and packaging industries in the US, Canada, and Mexico primarily. And that's what this last column is. So again, the problem, we've included the appropriate sections of the codes that we've pulled this information from and that applies. And again, the problem is they're going to be generalized. They're not going to tell you that you have to have 1 milligram of oil or particulate in your air. They're going to tell you you need to do a risk evaluation analysis and determine the appropriate level for your facility. So it's a little bit frustrating, but hopefully in the next few slides will kind of help you guys determine how to do that. The other thing to note on this sheet is the testing frequency. SQF, BRC do currently mandate minimum of annual testing. FSMA at this point does not have a specification. They tell you to kind of do it based off your risk analysis. And then of course we tell you to do it per your specification, and we can help you figure that out. What we're seeing in the industry is basically everything from quarterly testing to annual testing. And so at this point, I'm going to hand you guys over to Jason Vandagriff, our Associate Lab Director. He's going to run you through kind of our test equipment, tell you how we collect those samples, and run you through the first couple ways to do a validation of your system.
Hi everyone, thank you again for joining us on this webinar. I'm going to talk briefly for the next 4 or 5 slides here about TRI's analytical capabilities and sort of what happens when your collected field samples come back to us in the lab. Like James said, I also have one slide that touches briefly on how to validate the critical compressed gas system in your food or beverage facility. And like I said, I'll touch on that very briefly. This picture here is showing our Champion 35 flow section kit. This is the air collection sampler that nearly all of our food and beverage customers use. And I don't have the components highlighted here, so I'm going to run my mouse over the different components and explain each one of them. This here is the main air sampler manifold. All of our sampling media either connects to directly or screws inside this manifold. You can see here this is a 1/4 inch brass fitting, and this fitting will either be high or low pressure depending on what your setup is particularly, and your gas source line will will connect in directly to this brass fitting here. This red cup here contains our oil mist and particulate filter, and that screws directly into the manifold. And it will collect any oil mist or particulates as the air source flows through it, if anything's present in your compressed system. This small metal cylinder here contains the gaseous components. It will click on this quick connect fitting here that's on the manifold, and like I said again, that's what gets our gaseous components. This here is the Draeger moisture tube, and it fits in this moisture fitting right here, and that's what we use to determine moisture content, which ultimately leads to the dew point as well. Here's a picture of our Champion 35 in the field. You can see here is the gas source line coming directly into the manifold. Here's our, this gentleman here is collecting his gaseous components in the metal cylinder, as I explained earlier. Also over here is the Draeger tube in action, getting our moisture data for us. I'm going to talk briefly here about some of our analytical methods. These next couple slides, we're going to talk about kind of what we see in a standard gas or air sample that comes to our lab for testing. At TRI, we test all the main 3 states of matter: gas, liquid, and solid. This slide in particular touches on the gas portion of our analysis. Now, the gas component testing many times will not be applicable to our food and beverage customers. Many times our food and beverage customers are only concerned with moisture, microbial, and oil mist and particulate concentrations. But nonetheless, I want to touch briefly on the gaseous analytes of interest, just in case they are a critical factor that needs to be monitored in your process. And here are the gaseous analytes that we analyze for typically. That's oxygen, nitrogen, carbon monoxide, carbon dioxide, methane, total hydrocarbons minus methane, and halogenated hydrocarbons. Our gaseous components are analyzed with a highly customized GC-FID TCD instrument. It has a dual detector, two-channel detector system. And you can see here our total analysis time is only 37 seconds. You won't find a GC instrument in the world that can match our speed for this particular analysis. Our GC flame ion detector and thermal conductivity detector instrument is what allows us to give these 24-hour turnaround times to our customers and even same-day results if need be. This instrument is sort of what sets TRI apart from our competitors, allowing that super fast turnaround time. The flame ion detectors can only detect compounds with a carbon-hydrogen bond, as you may or may not know. So we use a nickel bed methanizer to do a catalytic conversion of the CO and CO2 to methane to analyze those two compounds. We do offer halogenated hydrocarbon analysis as well, using an electron capture detector to analyze for those species that may or may not contain a halogen, which is could be a chloride, a fluoride, or a bromide functional group on the compound structure. Now we may move on to hear what may be the more critical of the matter that you guys are more concerned with. That would be the solid and liquid contaminants. Our oil moisture, our oil mist and particulates are analyzed gravimetrically with an analytical balance. Our low level of quantitation for reporting is air volume dependent. The more air you pass through our sample filter, the lower our reporting limits can go down to. Some of our customers need to report as low as 0.001 milligrams per cubic meter, and we can, of course, accommodate that if need be. Moisture is analyzed with a selenium oxide reaction inside the Draeger tube. This is done by passing 25 liters of air through the tube. If your moisture is above only 2 parts per million, a reaction will take place in the tube, and we can report anything above that 2 ppm level. The dew point temperature is in direct correlation of the moisture content. It's a function of the water vapor pressure signature from the moisture content. We use a psychrometric conversion chart to determine the dew point at atmospheric pressure. We can also then convert that atmospheric dew point to your line pressure dew point if you need us to do that as well. Many of our customers request that. Halogenated oil vapor and or oil mist is analyzed by collecting this material onto a carbon tube, much like the same way that we collect our moisture tube with the Draegers. We then extract that halogenated oil content off the carbon tube with a proprietary desorb solution and inject an aliquot of that onto our GC ECD detector, just like we do with the gaseous components. Our mold and bacteria is collected much in the same fashion as our oil mist and particulate. It's collected on a special type of filter, and that analysis is also air volume dependent for your reporting limits. Again, the greater the air volume, the lower our detection limits can go. We require a minimum of 5 days for culture growth. If we see any culture growth, we will, of course, count that and identify the species as well. Now I want to discuss briefly, before handing this back over to James, about validating the compressed gas system in your facility. This can apply to anyone that may be on this webinar. At some point you may be part of a team, or you may manage a team that has to validate a critical system for a brand new or remodeled facility, or you guys may buy a new critical system and it needs to be validated at purchase. So this information can of course be helpful for that. This slide again is only going to touch briefly on this subject matter, but I did write an entire technical paper on this, on how to execute a proper compressed gas system validation. I'll be more than happy to send that out to anyone on this webinar today. Just email James or I, and I'll get the paper emailed back to you. It obviously goes into much more detail matter and can be very helpful. So just hit us up if you want it. The proper execution of the facility validation plan regarding any and all critical systems is ultimately directly tied to the overall success of an organization. The validation plan should define the installation qualification, which is the IQ, operational qualification, OQ, and the performance qualification, the PQ, of the compressed gas system. All critical components must be defined, and the upper and lower control limits of these components must be established to meet the overall quality standards of this process and product. Now I'm going to go ahead and turn this back over to James, and thank you again for participating. We look forward to answering any of your questions that may come up at the end here. Thank you.
All right, thanks, Jason. You guys probably either feel smarter or just a little bit dumber after listening to him. But either way, congratulations. You guys have made it through the worst part of this webinar, all the technical garbage that we needed to build just to be able to help you guys understand what you need to do in your facility. So what we're going to hit next is actually the parts that will be most applicable to you. How do you implement the knowledge of what your system is, the contaminants that are potential in it, your types of controls, filtration and dryer, and come up with a single report that you can use to validate your system, ensure safety, and use for compliance with any certifications or regulatory bodies that you're responsible for. So there's three common test schemes that we're seeing in the food industry, and there's probably 4 or 5 other ones that could potentially be used that are used in the medical, pharmaceutical, and some of the dive breathing air type areas. But we're going to focus on what we're seeing as the general practice for the food industry. The first type of testing scheme you can use is what we call a baseline analysis. A baseline analysis simply means you've had a system in place. It's been functioning for however many years. You've never tested your air, so now we got to figure out where your air is at and if that meets your internal quality standards. What we'll do is you send out a kit, you pull your samples, you get that initial report, and then we'll go over that data. From that data, if it's deemed appropriate for your use, you can set your control limits or critical limits, and you'll have an established test limit to go moving forward annually, semi-annually, whatever you guys end up on. So if you don't know what you need or where you should be, usually a baseline, what we call a no specification report, where we're not telling you a pass-fail, we're just giving you a quantitative measurement of what's in the air, is where we'll start you guys, and then from there we'll help you determine what the best path forward is. Another approach we're seeing a lot of people take is they're utilizing a historical trend. So that people who have been sampling prior to it becoming a regulatory or certification issue and have a history of their air test, they are plotting that out and basically showing a trend analysis that says, hey, this is where our air has always been. We've never had an issue with safety or quality during this time that was related to the air. Therefore, we know these limits are good, and as long as our air stays in this trend, we're good to go. The final way people are doing their schemes is through validation studies. So you can do a full validation study on a new facility like Jason ran through. And then you can also do a validation more in the FSMA meaning of the word, where you do a validation based off of the critical control items that are in your plant for compressed air. That's going to be filtration you've chose to put in line and dryers that you've chose to use to remove excess moisture. And so what that validation will look like is same thing. We'll do a sample, we'll pull the particulate, oil, moisture, microbial, and we'll look at the operating characteristics of your system. So if you have a refrigerant dryer, they generally operate around 0 degrees Fahrenheit for dew point. We'll want to make sure you exceed what you're below whatever that expectation is. If you're using a 1 micron filter, obviously there's an expected level of gain of particulate, and we just kind of focus in on that and use that to validate the controls that you have in place. One of the hardest things, and one of the conversations I have the most with customers that are coming online, is determining points of use and how to figure out where to sample in your facility at. So we work a lot with quality departments who aren't on the floor all the time in the mechanical sense, where they're running the lines and doing the testing themselves. So kind of framing this, there's 3 types of product use we got to be aware of as far as air is concerned. You have your direct product use, which we consider basically anything that touches the food or the inside of the packaging that the food's about to touch. So if you're blowing open bags and loading it, if you're inverting bottles and blowing brittle plastic out, if you're blowing excess flour off of breads, all of that would be your direct type product contact. The next type of point of use would be an indirect point of use. So for food facilities, this is primarily going to be our cleaning sanitation type use air. You do a clean in place CIP, and then you come back with air and you dry it down with the air wand. The food's going to run right over that surface next time you run the production. So most people will consider it indirect product air, and we have a little bit slightly different recommendation for that air. The third type of air used in facility plants is going to be your process air. Process air we don't test and we don't concern ourselves with a whole lot in the food industry unless you have um, specifications for certain pieces of machinery that have requirements for the input air. Then we can test to validate that for that machinery, so we're not causing issues with its operation. But as far as safety and food quality, we're not concerned with process air because it's going to stay in a completely contained loop. It's going to do things like fire valves, or move a piston or switch a branch on a set of piping. If it breaks, your machine will be down and you'll have a repair process in place that would address cleaning and maintenance. So for us, we're going to kind of ignore process air and focus on direct and indirect product contact air testing. The other bullet points here kind of talk about what we're seeing people do in the food industry as far as picking how many points of use or what types of points of use to test for. Obviously, you can do all points of use. It's very typical for our pharmaceutical, nutraceutical type companies who produce products in a much cleaner environment. So you'll see those guys test every single point of use, sometimes as much as prior to every lot product run. Pharmaceuticals produce just a little different than food. In the food industry, we don't see that as much in the pure bottling, packaging, manufacturing type facilities. Again, if you're in a more sterile environment, you may use that, and we can kind of discuss that offline. What we're primarily seeing are these other three. End of line testing is when you look at the point furthest from the compressor where the air is used in your facility, and you take a sample from that point, making the assumption that if that air is good and it's a representative sample of the air in all of the piping through all the filtration and drying in all the receiving tanks, that if it's good at that final point, it's going to be good throughout the rest of the system ahead of that. This gets tricky because you have to kind of know your plant layout, which is why the line diagram is good. If you have one compressor or multiple compressors feeding to a single expansion receiving tank that goes through one main branch line and feeds out to your production line, you basically end up with a single point of use end of line test. If that line comes out and hits a header and tees off and runs into multiple production lines, you'll end up, even if doing end of line testing, you'll end up doing one point of use test from each of the end of line branches. The other thing we see often is source testing. Source testing literally means testing at the compressor. So you'll test after the expansion tank. There'll be a sampling port that you can tap into, and we'll test there. This test we typically see in the food industry to contain more of those gaseous components that Jason said are often not looked at, as well as your particulate water, oil. I know we keep saying oil, and there's a lot of people who say they have an oil-free compressor or they're going to use food-grade oil. But remember, compressors, unless you have a water compressor, water lubricated compressor, which is fairly new and very expensive, so not very popular yet, or an oil-less compressor, also not as popular yet, you're still going to have some type of oil to lubricate the pistons and things inside the unit that could leach through a gasket, and more importantly, the air around the environment is going to get sucked into the compressor. Even if you're oilless, if your unit's outside and we're pulling in air, and your guys' real life scenario, we had a customer that was getting high oil readings, higher than what their critical limit was, and they have an oilless compressor, so they had no idea what was going on. It turns out they're parking their big rigs right at the compressor pad outside and leaving them running all day because it was in West Texas and 110 degrees and the truckers didn't want to get hot. So they have 12 hours of tanker trucks running, pumping in contaminants. They got compressed down and it compressed into an oil reading, and caused some product and quality issues. So that's why source testing is kind of important. You'll see, it'll give you an indicator of what's happening at your compressor prior to you seeing a problem necessarily at the point of use. So it'll give you a chance to catch anything that may be straying before it becomes expensive mechanical repair, or it becomes a contributing factor to a problem with the product. The other option we see people exercise, typically in very, very large facilities, would be a random sampling interval. You'll identify through your line diagram all your points of use. You'll classify them direct or indirect, and then randomly you'll select samples off of each branch and sample that. Usually it's a 10 or 25%, sometimes a 50% sample rate. So you take 2 or 3 points off this line randomly, and then same thing off the next line. If those results come back within spec, no worries, we move forward. If they come out of spec, you'll do a retest or an expanded test of multiple points on that line and try to identify if it's isolated to a single line or if it's a compressor issue. And so those are kind of the ways to identify where to test in your facility. What we see on average depends on, I mean, it's really dependent on the size of the facility. 1 to 16 points of use is kind of where everybody in the food industry falls. If you hit the 16 point of use mark, you're a very, very large production facility. Your typical single product type facility will end up doing 2 or 3 points of use in general. So once you figure all that out and we get our testing done, you'll have your audit coming up, and what we see a lot is people don't understand how the system works, what the contaminants are, where they should have tested, what point of uses they pulled from, or why they tested. And so they have all this paperwork and they get to their audit, and then the auditor starts asking them questions because that's what auditors like to do, and they don't have answers, and that's where they get themselves in trouble. So now even though they tested, they're still getting hit on their audit because they didn't understand what they tested. So there's a couple things to do to prepare yourself for an audit. The best thing to do is have paperwork always. So there's a bunch of items to include in your audit, and we have a bunch of this documentation as downloads available here on the webinar. The items that we would recommend including would be your line diagram with points of use identified, some type of SOP for testing that identifies your dryer, filter, a defined testing schedule, so how frequently should we be testing, and a defined testing method. Are we doing a trend analysis? Are we setting critical limits? Are we just doing a comparison to last year's results? And then have that SOP along with your reports from testing and a certification from the company that completed your test. So whatever analytical lab did it, they should be able to give you a certification. It's a new point of emphasis this year for SQF. The FDA has always recommended using certified labs. SQF specifically says you need to use an ISO 17025 accredited lab for air testing. So just make sure you ask for that if you're talking to anybody other than us. There's not a lot of us out there, so. The other thing I'd like to cover real quick is just questions that you're going to get asked from your auditor. I have a paper on my LinkedIn account. It has the top 5 or 10 questions the auditors ask, but we'll go through them real quick right here. Generally, what auditors are going to do is they're going to see your compressed air getting used in the facility and ask if you test it. You're going to say yes and open a can of worms. And so they're going to ask you how, if they can see the test documents. You'll provide all the documentation because we're now prepared. And then they'll start asking you questions. How many compressors do you have on site? What they're looking for is if you have a single test and 2 compressors, how you're validating both of those compressors. So again, it comes to knowing your system. If you have 2 compressors feeding into a single expansion tank that run together to give you enough capacity, you can treat them as a single compressor in a single test because they work together and it's a blended air that we're testing. But you need to know that to present that information to the auditor. So it's one of the most common hits we get back. People have multiple compressors. The auditor will see 3, 4 compressors out in the yard and only 1 test report and not think it's adequate. And the person who's hosting the auditor won't have the answer for them. Another question we get all the time is the types of use. Make sure you can define your types of use, direct, indirect use. And justify why that's your type of use to the auditor, because they may have a different opinion. But generally, if you can support and justify your use, they won't question it. And then the last question we get all the time from auditors, we actually took 2 phone calls today on it, is did you test micros from your compressed air? Um, the answer should be yes. It's written into SQF. BRC's adding it in February 2018 on their new release. FSMA addresses it as a point of concern, so you should be looking at your micro testing. Um, Micro testing, there's a lot of people who attempt to do it in-house. It's a little bit unique with compressed air, and auditors are kind of getting to the point where they're asking the questions now. So what you'll see is you'll have someone out there that has a sponge or a plate, and they're just blowing air from a hose on it for 20 seconds or 15 seconds or whatever somebody else wrote in your food safety plan, and then they're going to their in-house lab and plating it and not seeing anything and saying the air is clean. The problem with that is it doesn't meet the standards for testing compressed air. Compressed air has to be tested in a closed loop environment, and more importantly, you have to be able to quantify compressed air. You can't just say you have 1 milligram of oil in your air. You have to quantify it to a volume. So you have 1 milligram of oil per cubic meter of air. Just like CFUs for microbiological, you have less than 50 CFUs per cubic meter. So the problem with in-house testing a lot of times with microbiological testing is that you don't have a way to close the system and quantify flow and volume to get to that final reading that they're going to want to see. If you guys have any specific questions about that piece, we'll kind of address it towards the end. The pitfalls that we see, not having documentation is the biggest. Not having maintenance and quality on the same page. We had a customer that got hit on their audit recently because their maintenance department did not know that the quality department did the testing. And so when the auditor asked the person working in the area, they said, no, we don't test. It became a hit, and we were able to give them documentation to prove it out later. So just make sure your team's on the same page. And then the other one, big pitfall we see is people just not having basic understanding. Again, like we talked about, multiple compressors and not being able to justify why you've made the choices. We have all these sample documents for download. Everything we would include is there. So please download those and use them. Feel free to edit them. They should all be in an editable version. If you have a problem, reach out to us and we're happy to get that to you. We're almost done here, so what I'm going to do is hit some frequently asked questions, and then we'll address any questions that have been asked. So here's what we hear every day on the phone. I've been SQF certified for 4 years and I've never tested. Is this really necessary? The answer is yes, it is necessary. It's based off your specifying body. It's not TRI telling you to test. It's not ASI telling you to test. You chose to be SQF certified. It's a requirement of SQF or BRC or your FSMA validation process. Then yes, it's going to be a requirement for you. You can do whatever risk analysis you want and justify it out. You just run the risk of getting hit on the audits, especially now that we have very specific language requiring it. The other question we get all the time is we have in-house testing. Why should we change? That's kind of what I was just touching on. Compressed air testing is a little bit unique. It has to be done in a closed loop. You have to be able to quantify volume. If you have a method for doing that in-house, great. Continue testing that way. If not, that's where we come in with our equipment and help out. The third question, my maintenance facilities quality, whoever the other person is, department will not buy into this testing. What can I do? This is probably the biggest trick. Often quality facilities or maintenance are on different pages. Maintenance guys have been working with compressed air for 20 years and don't feel it's a danger. A lot of it comes to sometimes we get a conference call. But the biggest thing is just bring it to them. Show them, hey, I have this requirement that I have to meet. How can we do it? And even give them the information. We have this lab, and let them kind of lead the horse to water and let them choose to drink at that point. And that's kind of the best approach we've had with getting buy-in from everybody. The other thing the buy-in here will do is help us get everything signed off when the auditors come through. How often should I test? That question is hard to answer. Generally, it's going to be annually by certification up to quarterly. Generally, we align these with whatever other utilities you're testing, be it steam or water, or frequency of system maintenance. So if you're changing out your filtration semi-annually, you need to test to validate that filtration semi-annually. The big money question, how expensive is this? It has a pretty varying range. We run anywhere from $350 to $3,500 for an average site. Again, depending on how big the site, the more points you use, the more expensive. The most top end sites we have, they run in the $20,000 to $30,000 test range, but those guys are doing sterile air, requiring laser particle counters and on-site technicians. So it drives the cost up significantly when we have to do that. Who can you talk to? If you have questions, you can talk to myself. I can get you through the certification pieces. If it's technical, Jason's available. And we also have our lab director, Dr. Gala, who's available to address those concerns. Even after you sample, if you don't understand what they mean, we're here to help you kind of walk through that process. And then the last question, how do I determine what specification I need to meet? In general, you align with whatever certifying body you're going with. If you're under FSMA and FDA, you go that way. If it's SQF, BRC, GFSI. If you're testing to the interstate milk or AIB, then we'll align you with that specification and make sure you're doing the right testing. All right, so at this point, I'm going to mess with my screen for a second, and then we're going to see if there's any questions that we need to answer. Give me 1 second. Hey, Shannon, do you want to see if there's any questions and kind of run that piece of it?
Yes, I'll start off. I didn't know if you were pulling something else up. The first question that we have here, it says, will we get a copy of the different codes for the compressed air? And the chart shows that SQF, BRC, and FSMA and the GFSI codes that were in the actual presentation. And I do believe those are all up in that side over here where it says files. Any of those can be downloaded or uploaded to your computer. So if you go, you can move it up and down. You can download them all and maybe take a look at them after you get out of this presentation, and that way you have them for later. So I'm going to move on to the next question down here. All right, the next question that we have is it considered indirect if the air is used for sanitation of areas only after the product is in the package? For example, a can conveyor or something like that?
Yeah, great question. Again, it's going to depend on, is there a risk of exposure to the product after the cleaning? So if we are 100% packed, I don't know what type of can it is, but if we're a beverage facility and we run our soda through, it goes through the filler, gets the cap put on the can, and now the product's 100% sealed, and then you're talking about a conveyor past that point, most people will say, obviously, it can't penetrate the can, so we'll define it as non-contact air. We really didn't touch on non-contact air, so it's a really good question because it kind of confuses the issue. Non-contact air would be air just like this. It's final packaged past the unit, past the point where anything can get back into the packaging or touch the product. So it has no chance. We'd call it non-contact air. We define it as non-contact air, and we'd exclude it from any testing at that point generally.
All right, the next question that we have is it considered indirect if the air is used to reject product at an electronic sorter in a cannery?
So it depends again on the use, specific use. So if we're using it to reject product prior to canning, and so you're blowing product out that doesn't meet size or whatever the requirement that it's sorting for, weight, then yes, because it has it's actually considered direct product because it's going to touch the other product during that process, even that it's not ejecting. If it's talking about, if you're meaning sorting out cans that didn't fill to a right volume, and so the weight there isn't right, so it blows them out of line. Once the cans are sealed, again, no, it would be non-contact air at that point.
All right, the next two questions. The first one is, can we get the PowerPoints for this webinar? I am actually recording this, and it is going to be on our YouTube channel, which is ASI Food Safety Inc. So you'll get all of that, and I do suggest that you go to the top right-hand side over here and download any of the files that are there. The next question is, as an auditor, when I ask for air testing, how do I know that the risk analysis, what the risk analysis is if there are no limiting characteristic limits for dew point, water, ppm, or do I just look for the size of the filter as acceptable?
Yeah, it's still kind of a tricky thing to do in the food industry because there is no one giving us a specification. So it is going to be a risk analysis. So if we're marking the air as a low risk item, um, and you can look at the customer can look at the history of their plant and say we've never had a recall issue or a product quality or stability or any issue, and the air has always been in this realm, then we have to take them at their word and kind of accept that that's what it needs to be. TRI does have some recommended limits that we put out there as guidelines. Doesn't mean that they work for every facility, but 99% of the facilities, if they're under them, will be in good shape. The big things, if I was an auditor, I would look at is just what I warned everyone here to look for. Know your system. What type of dryer do you have? What should that air be dried down to? Because every dryer is going to have an operating characteristic, and same thing with filtration. What type of filtration do you have in place? Do you have a point of use filter? And are those things functioning as intended and designed by whatever engineer put that system together? So I'd really look at it as more of a validation of what they have if they haven't established their own critical limits. I would encourage everyone to pick a critical limit and do it based off of product use and current setup, because it does prevent issues like this from happening.
All right, the next question that we have is, does TRI Air conduct on-site gaps to determine the risk for one of these food companies? So in other words, does TRI Air have the capability to do the risk analysis for food companies?
So it's a well-timed question. Currently, we don't offer the service, but we are bringing it in-house due to the high volume of requests. We're going to start coming on site and not only conducting the maintenance, but making general recommendations off of industry standards and kind of letting people know what they're missing. If we do come on site to do the testing, obviously we'll help you identify the points of use, the type of dryer you have, so we know what we're looking for when we get out there. But we will probably never put ourselves to the role where we're telling you what your specifications or your critical limits have to be. That determination is really going to have to be made by food technologists, scientists in very, very familiar with your product and the effect that these contaminants could have on the product. But we will absolutely provide some pretty solid guidelines to follow.
All right, and I see Michelle has her hand up. If you could just type it at the bottom right-hand side, and I will read through that. What about vacuum packaging? Is this indirect, and how does it apply to food safety protocols?
Yeah, the vacuum packaging, we actually have plants that go both ways. Again, it's based off their risk analysis and how they perceive the words direct and indirect. So that's the blow molding and the vacuum packaging are the two that we see customers flip-flop on. I think what you're going to end up being held to in the long run is going to be a supplier or vendor verification or validation for whoever you're providing product to. And I would generally err on the side of caution. There's not that much difference, and usually food plants are set up with enough filtration you can meet the direct air requirements. But in making the determination, you just have to decide, if you're vacuuming, you're pulling down, you're touching the outside of the package, the food's never going to hit the inside. If the air is never going in the package, it's very indirect at best. Some people will actually say it's non-contact. So there's a lot of debate on it, and because our specs are so vague and wide open, it's hard to say. We kind of have to look at a case by case what exactly you guys are making and if it's being transported or if it's being filled in-house. There's a couple determining factors that we can talk one-on-one, and I'm happy to look at for you.
All right, the next question is, if a part ejects off equipment that's considered direct, and if the part is a reject and uses air, is that indirect?
Um, if I understand the question correctly, they're saying part, but I'm assuming it's a cap or something in like something for the packaging, a filler pad or a bag or something along those lines. Um, if you're just touching something that's never going to touch the actual product, it would be indirect at best and maybe even non-direct at that point. If we're talking about part, meaning a part of the product is rejected, and there's any chance that the air can spill over to product that's going to keep moving through the process, then we would have to treat that air as direct contact air.
All right, the next question is for the MAP or MAP, do we need to do extra tests if we have guarantee from the supplier?
Great question. So if you're doing some modified air packaging, using nitrogen or whatever, and you're getting big dewars of that sent over, and you're getting a certificate analysis, that's kind of been the standard up to this point. SQF, the 8th edition, does now have language specifically pertaining to that and requiring the testing um, of it. So yes, you would have to test that now to validate basically the COA you're getting from your vendor is accurate and that all the piping and items in the transport of that gas to where you're packaging is not adding a contaminant at the source of use or the point of use. So again, it's dependent on who you're testing for. SQF is the first person to actually write that in as a requirement, which if the industry follows suit, which it seems to be doing, it'll become a part of BRC and everything else shortly.
All right, the next question is, we only use compressed air to clean, so it is not used directly with ingredients. Do I still need to test?
So this is actually one of the more frequent questions we get, and it's going to depend on a lot of things. Primarily, it's going to depend on your risk assessment of the cleaning. So if you do a clean of equipment that the food's going to run across a conveyor belt, a meat slicer, whatever it is, and then your last step is to blow it down with air, and then there's no further validation of whether that equipment is sanitized. You're not doing protein swabs or something like that. Um, you probably will need to test. If you have a final step where you're testing, doing swab testing after every single cleaning, and you can say that no, we know it's not contaminated. There's nothing there because we've already done the swab testing, so the air couldn't have contributed to the contamination. That's kind of the justification we see with people who choose not to test. Um, if you're using air like that, and that's the only use of your air in your facility, you can just do a basic particulate water oil test, and your testing's down around $300-400. So we generally, again, recommend erring on the side of caution because you don't want to get hit for something silly on an audit like that. But if you don't feel you need to test, you just have to have a risk assessment, and you have to risk assess it out because it is a very low risk, and the likelihood of touching the product is so low. Then you could say because the low risk, you don't need to test it. And again, auditors can't argue that with you as long as you can justify it and you've done your due diligence and have thought the process through.
All right, we're going to take one more question, and that is biological testing of compressed air in a cannery. Is this necessary as the product is fully retorted? What would be the desired target organism for what we would test for?
I would probably have to know a little bit more about what they're using their air for to really answer the question. But in general, the limits that we're seeing in the food industry range from anything less than 10 CFU up to less than 100 CFU reporting as no growth. And then the way we do our process is when we receive it back, we'll plate everything and we'll report anything that grows. You can identify what you consider a concern. You can use the big three, big five, whatever theory you want, and have those listed as your points of concern. But when you pay for the testing, all the speciation and identification comes with that with us. If you shoot me an email at the end of this and we can kind of talk about your specific use of the air, I can probably give you a little bit clearer answer on that one.
All right, I just want to thank James and Jason for their time today, and especially thank all of you that have attended. And if anyone has any further questions that we have not addressed, please feel free to contact our main line 24 hours a day, 7 days a week, or contact me personally at 314-333-6206. I have our information up on the right-hand side over there. But I'm also going to get you guys Tri-Air Testing's information as far as being able to contact them directly as well. Be sure to sign up for the Learning Lunch on June 22nd, where we'll be discussing SQF Edition 7.2, the roadmap of changes to Edition 8. And have a great afternoon, everyone.
Hey, one more quick thing before you guys all sign out. Come see us at Food Safety Summit next week if you guys are in Chicago. Jason and myself will be at the booth and he'll be presenting there. So if you guys are in Chicago,